Hi everyone, welcome to this video looking at one of the key topics that's going to be in your GCSE, and so we're going to look at some revision here for factorising expressions. One of the words that I've just said there is expression, and you're probably thinking, what does that mean? It means that all of the questions we're looking at today don't have an equal sign, so they're not an equation, they're just an algebra statement that we're going to change the way it looks. Now, factorise means to put brackets into the expression, so it's the opposite of expand. So when we finish, our expression is going to be manipulated, it's going to be changed how it looks, it's going to have brackets in it. The other thing to note here, the key word is also fully, and that means that we're going to find the biggest factor or factors in each of the expressions rather than just any factor. The other way that might look in your exam, it might say factorise completely. Now, one of the biggest problems with a factorised question is trying to make the decision on whether it's going to be a linear factorisation, that means it's going to end up with having one bracket in its answer, or whether it's going to be a quadratic and have two brackets in the answer. So I hope sometimes as we talk through these questions I'm going to be able to explain how you spot the difference. So let's start with question number one here, because we've got a set of jumbled up questions here which I think is quite good practice for you. Have a look at the questions, press pause, give it a try, then resume the video and see whether you ended up getting the right answer. Now, question one is a squared plus 7a plus 12. So we've got three terms here within our expression. We have a squared term, a letter term, and a number term. And generally speaking, these types of expression will always be two brackets. This is what's known as a quadratic expression. So our solution is going to have two brackets on it. So let's put that in now. Now, I know that a squared can only be found by doing a multiplied by a. So I can immediately fill that into my answer, because if I was to do the opposite and expand this, and if you're not sure what I'm talking about there, watch the expanding revision video so we can see how we do something like this. A multiplied by a will give me a squared. So that bit's done. So all I know that I need now in my answer is to have some numbers here, and also between them some symbols to connect them with the a terms. Now, how we find these numbers is a really simple two-step method for a quadratic like this. Step number one, they need to multiply to make this number 12. So let's have a look here. Pairs of numbers that can multiply to make 12. Well, I've got 1 and 12, 2 and 6, and 3 and 4. And it doesn't matter actually if we have the same pair the other way around, so for example 4 and 3. And somehow I now need a pair here for step 2 that are going to be either added together or subtract one from the other to make this middle term. So the rule there is times to make this and add or subtract to make this. So here are my pairs that times to make 12. Which of these pairs can add or subtract to make 7? Well, the only pair that's going to work is 3 and 4. The other two can't make 7 in any combination of answers. So I'm going to have a 3 in one of the brackets, and I'm going to have a 4 in the other bracket. I've put them that way round, but it doesn't matter if you would have wanted to put them the other way round. So for my final stage, the stage 3, I need to decide on the symbols that are going to go in the middle here. Now, what's kind of most logical is to think about all the combinations we could have. We could have both of them positive. We could have both of them negative. We could have the first one as positive and the second one as negative, or we could have the first one as negative and the second one as positive. So those are the four permutations, those are the different things that we could have. What we want to end up with is two numbers that when we multiply them together it's going to be positive 12. And I know from my rules with negative numbers that means they're both going to have the same symbol, so they're either going to both have to be negative or both have to be positive. And that when I add them together, my outcome gives me a positive 7 as my answer. So let's just look at what the combinations would give us. Plus 3 plus 4 gives us plus 7, so that looks like that's probably going to be the answer. Minus 3 minus another 4 takes us to minus 7, so that's not going to work, so let's get rid of that one. Plus 3 subtract 4 is going to be negative 1, so that's not going to work either. And then minus 3 plus 4 is going to take us to positive 1, so that's not going to work either. So the pair that's going to work is when the 3's positive and also when the 4 is positive. And the beautiful thing about a question like this is most algebraic kind of actions have an inverse operation. Today we're looking at factorising. What we could now do is expand that, and if we do it correctly, we should end up with this original term, so we can double check our work there. Okay, right, let's have a look at question number 2. Now, question number 2 looks a bit more simple because we've only got two terms in this. We do have a squared term and we also have a letter term. So like with question number 1, we've got the first two parts but we don't have the third part. Now, as a rule, I now know that because I'm lacking the 3 parts, or later on we'll look at a special occasion where that's different, but because I'm lacking all 3 parts, this is going to be a linear expression, and this is going to have 1 bracket. So I'll put that bracket in now, and then we can work out what's going to go outside, which is known as our factor, and what's going to go inside, which is our remaining terms. One of the things I like to do, because it kind of helps me clarify in my mind what I've got here in terms of my factors, is I like to break the question down. So I'm going to write 20b squared as 20 times b, because that's what it means, because b times b makes b squared, and then I times that by 20. And 15b means 15 times b. So now I can help and I can look at what factors do I have, what things appear in both parts, because remember we're going to be trying to find the biggest factor here. So I've got a number in both parts, I've got 20 here and I've got 15 here, and knowing my times tables I know that the biggest number that goes into both of those is going to be 5. And then I need to look, do I have anything else in both parts? It could be a number, it could be a letter, it could be a symbol. And I can see that there's a b here and there's also a b here. So that can become a factor, so that can go outside as well. So 5b is going to be my biggest factor. That's going to help me fully factorise this expression. I've then got 2 choices. I can either think to myself, this divided by this will leave me the term that's going to go inside. Or, if you're not particularly comfortable with dividing, you can kind of think the other way around. What do I need to write here that when I times it by 5b, I end up with 20b squared? So either way we're going to end up getting the same term. It just feels whichever you're more comfortable with. So 20 divided by 5 is 4, or if you want to think of it the other way around, 5 lots of 4 is 20. And then b squared here, and we've taken one of the b's out as our common factor, so I know I need to have a b inside here as well, and I know that because I've written it here, but I also know that because b squared divided by b is b, or b times b is b squared. Second term here is going to be how we end up getting 15b. 15 divided by 5 is 3. The b's already been taken out as a factor, so it no longer remains here, and don't forget that there was a plus sign in the middle here. So it looks like our answer is 5b, then open brackets 4b plus 3. And as I said with the first question, you should now really expand that out, see what that gives you, and it should give you the question we started with. Let's move on to 3. We're going to follow the same process. I've got 2 terms here, so I don't have the squared and the letter and the number, so this one is going to be again 1 bracket. I'm going to do that technique where I break it out so I can see what appears in both parts. So this starts with 40 times c times c times c, because that gives me c cubed, and the other part's just 24. There's nothing there other than a number. So I'll structure my answer now. I've got a single bracket. I need to look what appears here, and there's only a number in both parts, so now I've just got to work my way through my times tables and ask myself, what's the biggest number that goes into 24 and also into 40, and I know that's going to be 8, and then I'm just going to divide through. So 40 divided by 8 is 5. I haven't used any of these c's as my common factor, so all of the c cubed remains there. 24 divided by 8 is 3. And then there was this negative sign in the middle that I need to write in to connect the terms together. Expand it out, see if it works. Question number 4 then. Just like the first question, this one looks like. We've got a squared term, we've got a letter term, and we've got a number term. So this time I know it's going to be 2 brackets, it's going to be a quadratic. So I write in my 2 brackets. I know in the front of each bracket I'm going to have the letter d, because d times d is d squared. I've then got to go through my 3 steps. So multiply to make 30 as step 1. So let's think about the pairs there. 1 and 30, 2 and 15, 3 and 10, 4 doesn't go, 5 and 6. My next number is 6, which I've already written, so I've exhausted the list of combinations there. So now we need to look at a pair off of this list that can somehow give us 7. 1 and 30 can't give us 7. That's either going to give us 31 or 29, so we can rule them out. 15 and 2 are going to give us either 17 or 13, so that's not going to work either. 3 and 10 could work if we do 10 subtract 3, so that's a pair. 5 and 6 are either going to give us 1 or they're going to give us 11, so that's not going to work either. So my pair is 3 and 10. Again, like I said on question 1, doesn't matter which bracket has which number in, so I'm going to write them that way around, but if you've written 10 in the first one and 3 in the second one, that's fine as well. So then it's step 3, deciding the symbols that are going to go in here. We could write out all of our combinations, so they could both be positive, both be negative, first one positive and the second one negative, or the first one negative and the second one positive. I need the combination that gives me negative 30 when I multiply them, so I know from my rules of negative numbers they're going to have to be opposite symbols. So let's get rid of that one and let's get rid of that one. And I know that when I add them together it's going to have to give me positive 7. So plus 3 subtract 10 is negative 7, that's not going to work. Minus 3 plus 10 gives me positive 7, so that's the pair that works. So the 10's positive and the 3's negative. Again, expand it out, see if it works. Now, question number 5 here is a very special case because it looks like, having done the 4 that we've just done, it's going to be a single bracket. But there's a special situation where if we've got the squared term and we've got the number term, that it could be a quadratic, and this is one of those examples. And for the eagle-eyed amongst you, you may well have spotted here that this e squared has a 9 in front of it, its coefficient is 9, and that's a square number. The 36 is also a square number. So we have a very special situation here where both of our terms are square numbers. So we've got a squared term with a square number and we've got a number term with a square number, and that's going to give us a very special type of quadratic which the exam board like putting in. That's a good one to spot, and it's going to be what's known as the difference of two squares. So this is a really simple one. Square root this, square root this. So the square root of 9e squared, what do I times by itself to get 9e squared? Well, that's going to be 3e, because 3e times 3e is 9e squared. Square root of 36 is positive 6 or negative 6, so let's put the 6 in. And then, and this won't make a lot of sense unless you've watched the video in terms of how to expand, one of these will be positive and one of these will be negative, because when we expand, it eliminates that middle letter term. So we end up with these two terms here giving us our 9e squared, these two terms giving us our negative 36, and these terms and these terms cancelling each other out to 0. Right, up to question number 6 then. So 3 parts: squared part, letter part, number part, 2 brackets. So it's a quadratic, and we're going to start by setting up our answer. We have a letter that goes in the front of both, f and f, because that gives us our f squared. We then need to list down all the pairs that are going to give us 80 when we multiply them. So 1 and 80, 2 and 40, 3 doesn't go, 4 and 20, 5 and 16, 6 doesn't go, 7 doesn't go, 8 and 10, 9 doesn't go, 10 we've already got, so there's our pairs. Which pair are going to somehow give us a total of 2 as a combination? Well, they're not, they're not, they're not, they're not, but they are. So one bracket has an 8 in it, one bracket has a 10 in it, although as I keep saying they could be the other way around. And then we need to decide our symbols in the middle. Multiplied together to make negative, that means we're going to need one of each. Added together they make plus 2, so this is going to end up being positive, this is going to end up being negative. Okay, question number 7 then. So this time here we've got a part of the expression here where the term has got some letters and some numbers, and another part where it's got some letters and some numbers, but it doesn't have our 2 key types of structure we're looking for a quadratic, which is the squared, then the letter, then the number, or the very special case we just looked at where both parts are square numbers. So this is going to be a 1 bracket factorisation. So we have our 1 bracket. On the outside we need to find our full factor, our biggest term, so let's start by breaking down what we've got here. We've got 36 multiplied by g, multiplied by g, multiplied by h, and on the other part we've got 27 multiplied by g, multiplied by h, multiplied by h. So what do we have as common terms there that can come out as our factor? We've got a number, and the biggest number that goes into 27 and into 36 is 9. We have a g in both parts. There's a g here as well, but there isn't another one here to make it a factor, so that can't go. We have an h in both parts, so that can go outside. We have another h here, but we don't have one here that we can pair it up with, so that's going to have to stay as it is. So let's go then. We've got 36 divided by 9 is 4. The g's already come out and the h has already come out, but there's a g left here, so that's going to go in. 27 divided by 9 is 3. The g and the h have already come out, but the other h hasn't. Don't forget the plus sign in the middle here. Expand that out, check it works. Number 8 then. and it's another one of those very special types. This is a square number, you just might not have spotted it because there's a 1 here, we just don't need to write that in algebra, and 1 is our first square number, and 64 is a square number because 8 eighths are 64. So it's that special type of quadratic where it's the difference of two squares, k and k, because that's the square root of this term here, 8 and 8, because that's the square root of this term here, 1 positive and 1 negative, so that if we expanded it, it would cancel out the middle term, so we would just be left with a square k squared term and a square number term. Number 9, this is the first one we've looked at where we have a squared term, a letter term and a number term, meaning it's going to be a quadratic, 2 brackets, but there is a coefficient here. On all of the other ones, on question number 6, on question number 4 and on question number 1, our squared term was just singular. There was just one of them, but here we've got 6 of them. So this makes for a very different technique, okay? And this is one that's going to be a little bit more long-winded, it's going to be a bit tricky to follow here. So let's try and go through this slowly. The first part we need to do is we need to multiply this term here, the A term, with this term here, the C term. So we're going to do 6 times 8, which is 48. We're then going to do the normal step, which is trying to find pairs that make that. So pairs that make 48. So we've got 1 and 48, we've got 2 and 24, we've got 3 and 16, we've got 4 and 12, we've got, does 6 go? Yep, we've got 6 and 8, 7 doesn't go, and 8 we've already reached. So a pair from this list that's going to make our middle term, which is 8. Well, they don't work, they don't work, they don't work, they do, and they don't. So it's 4 and 12. So what we now do is we, if you like, decompose our quadratic term here. We break it down into the 4 parts that would have made the quadratic. So we've still got our 6m squared, but in the middle here we've now got 12m and 4m, which is where we get our 8m from our 2 terms here, and at the end we've still got our negative 8. Notice I haven't put the symbols in here yet, but I'm going to need to do that now. How can I make plus 8 from these? Well, this is going to be positive, and this is going to be negative. And then I split this down the middle, so I end up with 2 terms on this side and 2 terms on this side, and I'm now going to do this like it was a linear question that I'm going to factorise. So, biggest thing that turns up here and here is 6m. What do I need here so that when I times this 6m I get 6m squared? Well, I need m. What do I need here that when I times this 6m I get 12m? Well, I need 2. On the other side, the full factor here and here is negative 4. What do I need here that when I times it by negative 4 I get negative 4m? Well, I need m. What do I need here that when I times it by negative 4 I get negative 8? Well, I need 2. And there's a check to do here. Do your brackets look exactly the same? Are they an identical term? And if they are, you've probably done right. So the solution then is this part here comes together with this part here. So our factors form to make one of our brackets, so 6m subtract 4. And the other bracket, which is identical, so we only need one of it, is our other bracket. So there's our answer, 6m subtract 4 and m plus 2. Again, expand it, see if it works. Final question, number 10, and it's another quadratic to finish with because we've got our squared, we've got our letter term, and we've got our number term. So 2 brackets, pairs that multiply to make 50, 1 and 50, 2 and 25, 5 and 10. Which of those pairs can make 5 in the middle? Well, it's going to be 5 and 10. N in the front of both brackets, because n times n is n squared. 1 bracket 5, 1 bracket 10. When I times these together, they've got to make negative 50, so they're going to have to be opposite symbols. Positive 5 means that that's going to be plus, and that's going to be minus. Remember, expand it out, see if that works.